Hello everyone. Today's video is going to be another short recap video about the camera. We discussed most of these camera options in class, but we're just going to tie them all together here in this video to give us a place to go review them if we need to. So when we look at the camera, there are a few specific fields that we care about. I'm going to have our main camera selected, and then I just want to go down through here and check off some of these options. So the first couple of options have to do with what the camera displays beyond our field of vision. Where it says clear flags, what that means is anything that is beyond this view of my 3D object, so anything out here where I haven't placed terrain or objects or things of my own, what should the camera render? By default, it always renders the skybox so that we have this nice horizon in our scene. If we want, we can change that to solid color, and now our camera only renders whatever color is in this background color selector. So clear flags determines what we display in the background, and if we just choose to display a solid color, then the background property displays that color. Projection we use differently depending upon, so we're skipping culling mask, we're not worried about culling mask, and the rest of them I've made a note of here. We've got projection, field of view, clipping planes, viewport rect, and depth. Projection has two options, perspective or orthographic. If we go into our game view, we can see that in perspective mode, the sphere looks closer than the cube. Perspective gives us a three-dimensional point of view in our object. If I change this to orthographic, now my view flattens out, so everything looks like it is the same distance apart. Hopefully it should be clear then to see that perspective view is what we would use for three-dimensional games, and orthographic is a good choice for using a 2D game, something where all of our objects are going to be on the same Z level, but we'll have different X and Y levels. Back to perspective for now. In perspective view, we have some more options we need to concern ourselves with. The first is field of view. If we look at our notes, field of view basically represents the zooming level. It represents how far zoomed in we are or how wide our camera is. So if we increase, this means we're making our camera wider. We can see more stuff, which means we're zooming out. If I make a lower number, that means I'm zooming in because my field of view is smaller. I'm focusing in on a single point. And by default, this guy is set to 60, so we're going to put it back to 60. Clipping planes has to do with how things are rendered in three-dimensional space. So in three-dimensional space, there are things that can be too close to the camera, and then there are things that can be too far away from the camera. This is governed by our clipping planes. The near plane, if I change this to something like 5, the near plane means that anything before this distance will not be rendered. So right now, anything within 5 units of the camera, which right now the sphere is within 5 units of the camera, will not be rendered. If I drop this down to 2, now we can see that it is rendered, or 1. And that controls at what point do I get too close and the sphere disappears. Obviously, if we're looking from the player's perspective, then the most natural thing would be to put something small. So 0.3 works well, because now we don't see any weird disappearing in front of us. But if we find that shapes aren't disappearing when they need to, if we find ourselves inside of shapes, then we may need to change our near clipping plane. Our far clipping plane is the same thing, but this is our maximum draw distance. So if I put this to 10, we can see how this changes. As I back up, sphere, or the cube, appears. A cube, and it's gone. Hitting that far clipping plane. So we can see that Unity represents, with this box, Unity represents what the camera can see, and that's controlled by our clipping planes. Viewport rect and depth are our last things to talk about, and they have to do with having multiple cameras in the scene. So I'm going to go ahead and add a new camera. And I'm going to turn this camera so that it's looking at our scene from a slightly different point of view than the first camera. So now we have this camera, and if we look at our preview, it's looking at our square and our sphere from the right-hand side, while our other camera is very close to the sphere and can see the cube in the background. So the question becomes, which camera will the game render when I hit play? If I run the game, we can see that it's using the second camera that I added. That is because of the depth property. The depth property is the priority of the cameras. A higher depth means that you will be rendered first. Or you will be rendered in front. So this main camera has a depth of -1. When our camera was added, it had a depth of 0. Because 0 is higher than -1, this is the camera that we see. If I drop this down to -2, and then check out my game, we can see that my first camera is now the one that is taking priority. So what if we want to see both cameras at once? Well, we can do that by making them the same priority, same depth, but changing the viewport rect. So viewport rect controls the dimensions of our camera. This controls how much space the camera takes up on the screen. By default, the camera starts in the bottom right, 0, 0, or bottom left rather. So it starts at the bottom of our screen. W is width and height is W is width and H is height. Width and height are a percentage of 1. So 1 means that it takes up the entire screen. Width 1, height 1 means fill the entire space. If I change the width to be 0.5, now my camera will only take up half the space allowed on the screen. So I'm going to do that with both cameras so that they only take up half the screen. But the problem is now, if I go to my game view, they both take up the same half of the screen. So I have to change the position of one of them. If they're both taking up 0.5 of the screen, I need to move one of the cameras 0.5 to the right. So I'm going to take my main camera, I'm going to change my X value to 0.5, which is going to push it to the right. And now I have this split screen effect. I have a camera on the left and I have a camera on the right. I can also use these recs to make one camera that takes up the whole screen and then one camera that takes up almost like a picture-in-picture, takes up a smaller part of the screen. But this allows me to control when I have multiple cameras, which cameras do I see and where. All right, so that wraps up our quick review of how cameras work in Unity. Thanks for watching.